Good day everybody. In today's video I would like to show how to connect a Dyness B4850 or even a B3 battery to one of these 3-phase Infinisolar inverters. Now do keep in mind this battery is too small to run this inverter. I'm purely just using this battery to show how to connect and establish BMS communication between the inverter and the battery. So if you come to the bottom of the inverter, you will find all of the communications ports. You have your RS-232, which is for your PC, as well as your USB, your dry contacts, and then your parallel connection when you connect more than one inverter. There is no BMS port on this. However, you do have this intelligent slot. So referring to that intelligent slot, you need to actually get your hands on one of these Modbus cards, which will then obviously slot in there, providing you with your RS-485 protocol will then assist you in communicating with the battery's RS-485. So generally when you remove the Modbus card from the packaging, your dip switches you have on this card should be set correctly for the setup already. However, let's just cover it for argument's sake. This is your switch number 2. As you can see, it's labeled on the PC board, and this switch is switch number 1. So switch number 1, only your first dip is in the on position. And coming around to switch number 2, dip number 1 is in the off position, 2 and 3 is in the on position, dip number 4 off, and then 5, 6, 7 as well as 8 is in the on position. So for the BMS communications cable between the inverter and the battery, we need to make up the following cable. The plug to the left, the purple plug, will be the cable I'm using for the inverter, and then I've crimped a plug to the right for the battery. Inverter side, or shall I say BMS Modbus card, pin number 4 will go to battery side pin number 3, and then inverter side, Modbus card side, pin number 5 will go to battery side pin number 1. Okay, so now that the dips is set properly, you will unfortunately not see clearly in this card slot, but there is grooves that you need to slot this card into. Once it's set in those grooves, you can just push it all the way in and obviously insert your screws as well. So for the dip setting on the battery, note the setting needs to be done while the battery is in off state. If you make any changes to this dip setting while the battery is on, then the changes will not have any effect whatsoever. So make sure it is in the off position. Currently is off. Looking at the dip switch block, dip number 2 you need to put in the on position. So dip number 1 is off, dip number 2 is on, dip number 3 and 4 is off. As for your slave batteries, when you connect multiple batteries in parallel with this one, it's only the master battery that has this dip setting. All of the following slave batteries you should connect to all off. In other words, dip 1 off, dip 2 off, dip 3 off, as well as dip 4 off. Okay, the Modbus card is installed, dip settings is set, and the cable is made. Let's hook everything up. As mentioned before, the purple side of the cable I made for the inverter. that can go to either one of these two RS485 ports. Doesn't matter which one you use. Then for the battery side, I've crimped the grey plug. That will go to the CAM 485 in port. As for your slave batteries, once you have additional batteries added on, you will then run a normal networking cable from the out to the next batteries in, and then from that batteries out to the next batteries in, and so forth. Okay, the setting is set. We can start up. I would like to mention I do not have AC connected to this inverter as yet. I'm purely going to start it up from the batteries DC, as this is only a simulation to show how to connect BMS Communication. Powering on the battery, keeping the switch pressed in, battery is starting up. The inverter is not yet on. We actually need to press the on button, keep it pressed in, and then wait for the inverter to engage. I don't think you can see what's going on the LCD display due to the bright backlight. However, just give it some time. We should see more details in a moment once the backlight goes off. Okay, the inverter just started up. From the battery icon, it's pushing power through to the light bulb icon, which is your load. Just waiting for the backlight to die down. There we go. So you should be able to see better now. You should see something written at the bottom here saying battery LI or LI BAT. That is your indication that BMS Communication is established, which you can see just now. LI BAT. That is proof that you have BMS Communication from the inverter to the battery connected. It is up and running and working well. Thank you very much.